So we're given r and theta in polar coordinates, and we want to represent this two different ways, given that theta is between negative 2 pi and 2 pi, and we also want to plot this. So it's always good to plot it first. Okay, so r is 4. That means you want to have a circle with radius 4. Theta is negative pi over 3. We know that this is 0. So negative pi over 3, we have to go clockwise pi over 3. So the angle between this point and the origin is pi over 3, which is, in other words, like 60 degrees. So this is 4 comma negative pi over 3. So in order to get two different representations, I'm going to change r and theta. Okay. So first I'm going to change theta. So keep r the same. For theta, I can add 2 pi to it, and I don't change the point. And the idea is, I'm currently at 4 comma negative pi over 3. If I go one time around the circle, negative pi over 3 becomes 5 pi over 3. So I still end up at the same point. So it is equivalent. Okay, now what if I change r? So I change theta here. Let's change r. Well, r, the only choice for r is it has to be the opposite sign. So here it's negative 4. What happens to the angle? Well, if I were to have negative 4 comma negative pi over 3, it would throw me to the other side. Okay. And the difference in the angle is actually pi. And to convince you to that is, well, this angle right here, think of it as 5 pi over 3, right? Think unit circle, we said it's 5 pi over 3. Now the second angle is 2 pi over 3. Because again, that's just unit circle facts. So the difference between 2 pi over 3 and 5 pi over 3 is 3 pi over 3, which is pi. So this is always going to be true. Whenever you make the angle or the radius the opposite sign, if the 2 points, if you connect the 2 points like this, it makes a straight line, which is 180 degrees or pi radians. So the way to go back to the other point is either add or subtract by pi. Here I'm just going to subtract by pi. So I take negative pi over 3 subtracted by pi. I get negative 4 pi over 3. Okay, so these are my two additional polar representations. Now for number 2, I have 16 comma 5 pi over 2. So the radius is 16. The angle is 5 pi over 2. I'm going to make a circle with radius 16. 5 pi over 2 is the same thing as 2 pi plus pi over 2. So you may be wondering how I did this so fast. Well, think of 5 over 2. That's 5 halves, which is the same thing as 2 1/2. But I have to introduce pi because it's 5 pi over 2. Okay, so 2 pi, we know when you add or subtract 2 pi, you still end up at the same spot. So I'm going to ignore that, and I get pi over 2. Pi over 2 is just 90 degrees. So my point is over here. Okay, so I'm going to have two additional polar representations. The first one, I'm going to mess around with the theta, and then I'm going to change the r for the other one. Okay, let's do the theta first. If I'm going to change theta, I better keep r the same. Again, you don't have to keep r the same, but that's just simplifying it. That's just like the easiest way to do it. Change one at a time. Why change both? It's more work. Okay, so if r is 16, what's another way of writing 5 pi over 2? Well, I said over here it's the same thing as pi over 2. So I can just write that as pi over 2. Okay, if r is negative 16, right, we have to change the sign. Currently r is positive 16, so you have to make it negative 16. Well, what happens to theta? Okay, let's pretend we have negative 16 comma 5 pi over 2. Like, let's say we just changed r. That would take us over here. right? This is 16 comma 5 pi over 2. So like we said, whenever you put either r or the theta the opposite sign, it takes you to the opposite side. And this is a straight line. It's the y-axis. So the difference in the angle is pi, right? Y-axis is a straight line. Straight line is 180 degrees, or pi radians. So how do I go back? So let's say I'm over here. How do I go back to this point? Well, I can either add or subtract by pi. Now if I add pi, I'm going to be out of this 2 pi range. So I better subtract by pi. So if I subtract by pi, I get 3 pi over 2. So these are the answers to number 2. Okay, let's go to number 3 now. We're given a point in polar coordinates. Again, think r comma theta. We want to convert the point to rectangular coordinates. In other words, x and y. So take your polar coordinate and convert it to x and y. I think the easiest way is to draw this and use common sense, basically. R here is -1. So think the radius as circle with, the circle with radius 1. So this will be -1, 1, 1, and -1. And then we have 5 pi over 4. In order to simplify this, just to make it easy on us, pretend like it's 1 comma 5 pi over 4. 5 pi over 4 is in the third quadrant. This is 1 comma 5 pi over 4. If we make r negative, that will throw us to the other side. So it forms a straight line. So that would be -1 comma 5 pi over 4. So what point is this? Well, we know 5 pi over 4 is of the form of pi over 4, right? So if we have, like in the third quadrant, this is -√2 over 2 and -√2 over 2. So if we throw it in the first quadrant is always positive, right? The x and the y is always positive. So that would just be √2 over 2 and √2 over 2 as the x and the y. Right. Okay, now let's move on to number 4. So pretend it's 2 comma 7 pi over 6. So with 2, it would have circle radius 2. And then 7 pi over 6 is in the third quadrant. So the -2 would take us back to the first quadrant. So we have to draw a straight line. So you may be wondering, what angle is this? The key to identifying what angle it is by looking at the denominator. So we know that it's over 6. So this would be pi over 6 in the first quadrant. Okay, so what I want you to get out of this is basically a triangle. So pretend like this is a triangle, a right triangle rather. This is the radius, which happens to be the hypotenuse. The angle is pi over 6, which is 30 degrees. And so this would have to be 60 degrees. So it's a 30, 60, 90 triangle. And if you have memorized this, it makes it very easy. So if the hypotenuse is 2x, the side with the 30 degree is x. The opposite side of 60 degrees is x root 3. So for us, the hypotenuse is 2. The side with the 30 degrees, or the opposite side of 30 degrees, is half of that. And then for 60, it's root 3. If you don't have this memorized, you can also use sines and cosines, or rather unit circle facts. We know for 30 degrees, it's root 3 over 2 comma 1/2. But here, this is radius 2, so we have to multiply these by 2. So the x is root 3 and the y is 1.